We use Descartes' rule of signs to help us determine if there are positive roots, negative roots, or complex roots by examining the sign changes.
Okay, so I've got positive x to the fourth minus 3x to the third minus 8x squared plus 12x plus 16. Please notice that I'm just looking at the sign changes. All right, let's count the number of sign changes. All right, so here's 1, went from positive to negative. That's one sign change. Now to go from negative to negative, that is not a sign change. Here is another sign change to go from negative to positive. That is another sign change. But to go from positive to positive, that is not a sign change. So the only two places where I have a sign change are here to here and then here to here. That's 2 sign changes. Two sign changes tells me that there are going to be 2 positive roots. All right. Now, let's examine the negative sign changes. I'm going to replace x with negative x, and I'm going to simplify. Okay? So let's divide this up because these right here represent our positive sign changes. And so now I want to examine the negative sign changes.
Quite simply, I am just going to replace the x with the negative x. And this is what my equation will look like.
Okay, so we're going to examine the negative changes. All right, negative x to the fourth. That would be like negative x times negative x times negative x times negative x. And I don't know if you need me to write that down for you, but I can simply explain to you that a negative raised to an even power is always going to be positive. Perhaps it would be helpful if I just wrote it down right here. Negative x times negative x times negative x times negative x. The answer is going to be positive x to the fourth. So this is x to the fourth. All right, negative x to the third. Well, let's examine. If we're only looking at 3, so we're looking at negative x times negative x times negative x. Well, if you need me to write it out, I certainly will. However, perhaps you recognize that when you take a negative number and you multiply it 3 times, a negative times a negative times a negative is going to be equal to a negative x to the third. So that means that what we have here is we have a negative 3 times what turns out to be a negative x to the third. Well, that negative 3 and that negative x to the third cancel out and becomes positive 3x to the third. So I have x to the fourth plus 3x to the third. Then over here, again, let's take a look at negative 2. Let's take a look at 2. Negative x times negative x. Well, what does that equal to itself? Negative x times negative x is simply equal to positive x squared. Okay, so that means that this simplifies to positive x squared. However, we're still multiplying by a negative 8, which means that this is a negative 8x squared. 12 times negative x, that's pretty simple. That's going to be a negative 12x and then plus 16. The general rule of thumb is when you are replacing an x with a negative x, the odd powers end up being changed. The odd powers. So notice what we ended up with down here was a positive x to the fourth, positive 3x to the third, negative 8x squared, negative 12x, and positive 16. So in other words, the odd powers ended up changing signs. The even powers stayed the same. And that is a general rule of thumb. So now that we have the signs, let's examine the number of sign changes. Positive to positive is not a sign change. Positive to negative, that's one sign change. Negative to negative is not a sign change. Negative to positive is a sign change. So we have two negative roots. The number of sign changes is equal to the number of roots that we have. So we have two positive roots and we have two negative roots. All right. Now I need to make a little table for you here. Total of 4. I have one possible scenario where there are two positives and two negatives, and then there would be, therefore, these are positive reals, negative reals. That means they actually touch the x-axis. And then complex roots, that would be 0, because of the sum of this column has to be equal to 4. Now there's some fine print in Descartes' rule of signs that says if you are able to subtract 2 from the number of roots that you have, then you must do so, because that means there may be another possible scenario. 2 minus 2 would be 0. If there was 0 positive roots and there were 2 negative roots, then that would mean that there must be 2 complex roots.
This represents the second scenario. In order to get the third scenario, we must now subtract 2 from the negative roots as well.
So there are 2 positive roots and 0 negative real roots. That would mean that there would be 2 complex roots.
There is one additional scenario where there would be 0 positive, 0 negative, and 4 complex roots. This represents all of the possible combinations using Descartes' rule of signs.